Hey everybody, new lesson, section 8.2, special right triangles, 45, 45, 90, and 30, 60, 90s. And these are kind of cool. I hope you're going to like them. So let's jump right into it. All right, special right triangles. Once again, we name them by their angles, and they are both named 45, 45, 90. 30, 60, 90, of course, they all add up to 180 because they have to, but that's what the two special right triangles are. Here we go. Here's what makes them special. Okay? All right, 45, 45, 90 triangles. All right, here's where it comes from. We're looking at a square here, obviously, okay? Side lengths are all the same. Side lengths are all S, and they're labeled as such, right? Okay, now, every angle is 90 degrees. But here's what we're going to do with this. We're going to make a nice little diagonal here that cuts this sucker in half. Okay. Now, a square is a rhombus, right? And a diagonal of a rhombus cuts the opposing angles in half. So these two 90-degree angles here and here are cut in half to make 45-degree angles. All right. So now, by the magic of video here, we're actually just going to lop off this side and not look at it, okay? Bam, it's gone. This is what I've got left over there, okay? We've got the two sides. We've got the blue diagonal that I'm just marking as H, and these two 45-degree angles here and here, right? Okay. Now, let's use the Pythagorean theorem and find out what this tells us. We can find the hypotenuse by taking the side length squared. A squared plus B squared equals C squared, right? Only I'm using different letters. S squared from here, S squared from here equals H squared, right? Right. Okay, following the math. S squared plus S squared is 2S squared. Okay, and I just flipped them around here, okay, just so we can see it a little easier. That's the only difference between steps 2 and 3 there. So if H squared equals 2S squared, and I take the square root of both sides, we come out with the square root of 2S squared. Well, the square root of S squared is S. All right? So what we come to find out is that no matter what S is, the hypotenuse is going to equal S times the square root of 2. Okay? Doesn't matter what S was. All right? We come out with an answer that says the hypotenuse is S times the square root of 2. Okay, and that is going to work out for any 45, 45, 90 triangle, which leads us to Theorem 8.5. For any 45, 45, 90 triangle, the two legs have the same length, and the hypotenuse is that length times the square root of 2. So the two legs would have whatever same length it is. Hypotenuse is S times the square root of 2. Nice and simple. Going to happen that way for every 45, 45, 90 triangle. So what do we do with it? We work it, use it to find answers to problems. Looking at this one, I've got a leg that's listed as 5, right? Okay. So what does that give me for A and B? Then I've got some other examples that are going to be a little more challenging as we go through it, but in every case I need you to notice the side lengths or the legs, sorry, let me go back here again, the legs, the sides next to the right angle, are going to have to be the same, and the hypotenuse across from the right angle is going to be multiplied by the square root of 2. So, challenge yourself, give them a try, here come the answers, okay? So for this first problem, fairly easy. If this is 5, then A must be 5. And the hypotenuse must be 5 times the square root of 2. Straightforward application of the theorem we just looked at. All right? How about C and D? Now, the hypotenuse is 3 square root of 2, so the legs must both be divided by the square root of 2. They must both be 3. All right. Now, E and F have to be the same, but this time we got a 10. All right, so E and F must be 10 divided by the square root of 2. Now this is what we call rationalizing a denominator here, guys. We can't have a denominator that's got a square root on it, okay? So to get rid of it, we multiply it by 1. Notice that this is 1. It just looks funny, huh? Okay, but we multiply it by square root of 2 over square root of 2 because that makes this turn into a 2. When we multiply square root of 2 times square root of 2, it becomes 2. Therefore, we end up with 10 times the square root of 2 on the top and a 2 on the bottom, and our answer, E and F, are both equal to 5 times the square root of 2. Finally, on G and H, we got this. Now, H must be the same, must be H times the square root of 2, 8 times the square root of 2, and G is 8 times the square root of 2 times the square root of 2. Once again, these two, square root of 2 times the square root of 2 makes 2. So our answer for G is that it's 8 times 2, or 16. Okay? So I hope you can follow those along. If you need to, go back, watch them over again, and see if they make sense to you, all right? Because more of the same or more similar is coming up. We are talking now about 30, 60, 90 triangles. Okay, we're going to have the same kind of thing coming up here. A little bit more complicated though, okay? For 30, 60, 90, we're going to look at an equilateral triangle. Now what we know about equilateral triangles is that every one of the angles has to be 60 and every one of the sides has to be the same, and I'm just calling it X for the time being, okay? But if we take an equilateral triangle and create a line that cuts from that vertex down to this side, okay, if you remember some of the properties we studied before, well, we know for a fact that for an equilateral triangle, that altitude is the perpendicular bisector of the opposite side. So this is 1/2 x, and this is 1/2 x, all right, to make our total of x, right? Okay, once again, we're going to wipe out half of the picture and just look at the triangle that was created when we took the equilateral triangle and cut it in half. This is now 30. That's still 60. Here's our 90. Okay. This is our half of x that we started with, and here's the x that we started with. Now, just to make it simpler, I'm tired of looking at fractions, so instead of calling this 1/2 x and this x, is it cool if we just call this b and 2b? I hope so, because same thing applies, right? This short part times 2 still gives us the hypotenuse, right? Which is one of the first things we're going to find out, okay? That in a 30, 60, 90 triangle, the short leg times 2 gives us the hypotenuse. Now with that information though, we can go back and use the Pythagorean theorem, which says a squared plus b squared must be c squared, only now it looks like that, right? Following through with our math, a squared plus b squared equals 2b squared, because that's the value I can put right in here, huh? Okay, so a squared plus b squared equals 2b squared. That equals 4b squared. We subtract the b squared, I end up looking like this. When I take the square root, I got this. When I square root that b squared, it turns into a b, and we find out that a, no matter what, is going to be b times the square root of 3. Okay, so we have a pattern now where both of the other sides can be listed in terms of that short side. So the shortest side, which is opposite the 30-degree angle, whatever that is, well, you multiply it by 2, you get the hypotenuse. You multiply it by the square root of 3, you have the long leg. Okay, and here it is in words. For 30, 60, 90, the short leg tells us about the other two sides. You multiply that short leg by the square root of 3, and you have the long leg. You double the short leg, you have the hypotenuse. Okay, another way of putting it, in any 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is equal to the shorter leg times the square root of 3. Okay? And once again, the short leg is always across from the 30-degree angle. Okay? And summarized. Here's how we use it. Here's 6 problems for you to mess with. Find A, B, C, D, etc., etc. Pause. Answers will be coming shortly. Okay. We got 9. Well, plain and simple, B is twice that, and A is 9 times the square root of 3. For CD, we got a hypotenuse of 14. Therefore, C is half of 14, and D is 7 times the square, is that half, 7 times the square root of 3. E and F, hypotenuse is 20 times the square root of 3, so F would be half of that, or 10 times the square root of 3. E, then, is the short leg times the square root of 3. Once again, square root of 3 times the square root of 3 is 3, and E must come out to be 30. Good. Next one. Long leg is 8 times the square root of 3, so the short leg must be 8. Hypotenuse must be 16. I for J and K. Short leg is 5 square root of 3. Means hypotenuse is 10 square root of 3. And then the long leg is 5 square root of 3 times the square root of 3, or 15. Last one. M and N. If the long leg is 21, the short leg must be 21 divided by the square root of 3. Once again, we'll rationalize the denominator right here. You end up with 21 times the square root of 3 over 3, or 7 times the square root of 3 for M. Finally, the hypotenuse N is double the short leg. And I hope that makes sense. Again, slow down if you have to. Go back and watch it over again, because we will have some harder problems. I will let you look at these. Pause. Here we go. Okay, the answer's coming. All right, here first of all we're going to look at this left-hand triangle in order to find C. That gives us A gives us D gives us B. Once again, we're looking at 2 triangles, 1, 30, 60, 90. First, it starts us off. In the second, undo that. The second triangle is the 45, 45, 90. It's over here. Okay? All right. For problems like these other two, I want you to picture a dotted line that goes here, 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 right? Okay? I know that's ugly, but it's the way it goes. All right. Since these are parallel lines, this dotted line must have the same length as that side of the other side of the rectangle, right? So with this 2 square root of 3 and this 30, 60, 90 triangle, we can solve for the different parts. Okay, long leg is 2 square root of 3. Short leg then must be 2, or long leg divided by square root of 3. Okay, hypotenuse must be doubled. All right, F, check it out, is this total of 6 minus this 2 part. F must equal 4 as well. Answer coming. Hope that made sense. All right, so do the same thing here. Picture a dotted line right there. That dotted line must be 6, and that gives us some information about the rest of the triangle. Here comes your answer, or the rest of the problem. Here comes your answers. Are we good? Hope so, because I'm done. Have fun.